Hey, mathematicians, this is Mrs. Shopper. We're talking about rotations. We're going to be talking about rotations. Here we go. A rotation about a fixed point. That fixed point is called the center of rotation. So the C is your center of rotation, and it gives you your degrees. All right. If the point is the center of rotation, then the image and preimage are the same point. All right. But if the point is not the center of rotation, then the image and preimage are the same distance from the center of rotation. All right. And then the angle of rotation is what is formed. So notice how these two sides are the same length. Okay. Now, here's a big thing I need you to remember. When we do rotations, they are counterclockwise. All right. So if it says it's a 90-degree rotation, that means it's 90 degrees counterclockwise. That's super, super important. Super important. We assume the rotations are counterclockwise unless it says something else. You got to keep that in your head. Okay. So like we talked about with reflections, there were some rules. With rotations, there's also some rules. Here we go. A 90-degree rotation, which means it's 90 degrees counterclockwise. This is your rule. You go from XY to opposite Y, X. If you have a 180-degree rotation, no, honestly, 180 degrees is clockwise, counterclockwise, same thing. Okay. You would do negative X, negative Y. You just take the opposite of each of them. For a 270-degree rotation counterclockwise, which is 90 degrees clockwise, this is why it's important to understand which direction we're going. You're going to switch the Y and the X, and you're going to find the opposite of X. So making sure you jot these down on a note card and kind of have it out. Maybe you have your translation ones on the same note card, so you just have that little reference point. So that's what we're working on. So here we go. A hexagon is shown below. What is the image of the point T after 90 degrees counterclockwise about the origin? Oh, shoo. Thank goodness it's the origin, right? So go back here, 90-degree rotation counterclockwise. It's from XY to opposite YX. And so I'm going to write that down because I don't want to make any mistakes in here. XY to opposite YX. And if I make a mistake, well, I'm human. It happens. All right. So J, 1, 2, 3, 4, 1, 2, 3 is at 4, 4. So J prime, all right. So J prime is going to be at opposite Y. Opposite Y and X. So it's going to look like that. And then G prime, right now it's at 1, 4, is going to be opposite Y, X. D prime, which is at 0, 3, is going to be opposite Y, X. T prime, which is currently at 1, 2, 3, 4, 5, 3, is going to be opposite Y, X. S prime, which is at 1, 2, 3, 4, 1, opposite Y, X. And R is going to be at, which is at 2, 1, is going to be opposite Y, X. So I'm using the algebraic rules to show you. All right. Now it says, what is the image point of T? But I just kind of walked through it. So hopefully you're getting the feel. 90 degrees counterclockwise, opposite Y, X. Opposite Y, X. Okay. All right, determine the angle of rotation that would map D onto D prime on the polygons below. All right, so here's D. It's going to go counterclockwise. Gosh, how do I figure that out? Well, this is a hexagon. So if I draw my diagonals, $60, $120, $180. No, $60, $120, $180, $240. It's going to be 240 degrees. Now, because we assume it's counterclockwise, we don't have to write counterclockwise, right? So it's got 6 angles. 360 divided by 6 is 60, and it's 4 of those. Okay. Let's go D to D prime. 1, 2, 3 stops. I've got, let's see how many sides I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 10 sides. And any moment my dog's going to bark because my daughter's getting home. Okay, so 10, 1, 2, 3. I'm going 3/10 of the way. So I'm going to take 360 degrees divided by 10. That's how many sides there are. And then I'm going to go 3 spots. So 36 times 3 is going to be 108. So it's 108 degrees counterclockwise. 108 degrees counterclockwise. Now, another option is I could have gone 3/10 and set up a proportion to get this. All right. Let's try another one. Given the equation of the line after a 1, oh, this one's so fun. All right, given the equation of the line, y equals negative x minus 2. So that's the picture we've got here. After a 270-degree rotation about the origin, then describe the relationship between the equations of the image and pre-image. Okay, so here we go. If I have, I'm going to pick 2 points on my line. Okay, I could even pick 3. So I'm just going to call them A, B, and C. So A prime, I'm doing 270-degree rotation. Now, we want to make sure we get it right. 270 is y opposite x. Y opposite x. Okay, so I'm going to say that xy is y opposite x. Did I say that right? Yep, y opposite x. All right, again, I got to double check, right? I don't want to make a mistake. And if I do, I'm human. You know, we talked about that. So A prime, so at A is at negative 2, 0. So it becomes 0, 2. And then B prime, so B is at 0, negative 2. That's going to be negative 2, 0. And C prime is going to be 1, 2, 1, 2, 3, 4. This one's at 2, negative 4. That's going to be negative 4, 2. So what I do is I pick a couple points and I take each of those points and rotate them. And then what I do is I plot those out. So 0, 2, negative 2, 0, and negative 4, 2. Why is that not working right for me? Oh, shoot. This is supposed to be negative 2. Negative 2. That's where I made my mistake. See? Okay, I made a mistake. It just happened. There we go. So when I graph these, that's going to be the line rotated 270 degrees from the origin. And what do we know? The relationship is they're perpendicular. If I find my slopes, they're going to be perpendicular. Okay. All right. So here you go on your homework. You've got a couple assignments, to do, and then I want you to do these 2 problems as well. Have a good day. Bye.